So I think today we'll make a clock, and I take very little credit for this clock. This is the brilliant work of David Johnson Davies, who has a magnificent site called Technoblogy. I hope I'm pronouncing it right. And he works predominantly with the A-Tiny 85s and some of the new AVR chips, and just produces the most beautifully put together projects, and this one is a lovely clock. So I built it, and you can see it there in the background on the breadboard, pretty much as David had intended. And my next thing to do was to use a 3D printer to design some sort of housing to put all this together. So with a micrometer, I measured the 8x8 little LED matrix that makes up the two halves of the clock, and some other bits and pieces like switches and so forth. And then it was just a matter of getting the right software and building it. Okay, just going to show you a couple of things that I've learnt on FreeCAD doing this project. I'm going to start on part, and I'm going to put a cube in there. And then when you click on the cube, where are we? Go to model and go to data. We can see the size is basically 1 centimeter by 1 centimeter by 1 centimeter. So on mine, I want it to be 100 by 90 by 2.2, let's say, millimeters. And then I have to zoom out, and I'm using my cursor keys here to move it around. And it's really hard to see what that is until you press this orthogonal or axometric view. Okay, so now the next thing to do is to round these corners off. So you just select the corner, so like this one here. Now I'm going to go to part design and choose this one here, which is fillet and edge. And then you select the radius. So I'm going to go to, let's say, 4 millimeters. And I'm going to do it for each corner. The same, just to round off these corners nicely. Four millimeters, good. And you see you can't see the back one easily. You can do lots of different rotations, but I've actually found if you go into wireframe, this one pops out. And that's pretty easy then to get that last one. Nice. Okay, so that's stage one. Alright, so now we want to punch a hole in the corner up here, let's say to start with. So this is the sketcher here, and actually, there's a classic mistake that I've done before. You need to select the face that you're working on. So I'm going to go back to the top here, and then select sketcher, and then go back to wireframe. And that way the sketch will be actually linked to that edge, to that face, which is what you want. Now again, I'm just going to use my cursor keys to zoom in here to get right on the corner, and then you'll see up here there is a create a circle. So here I'm just going to select the center of the circle, and then the radius to be 1.5, which gives us a diameter of 3. So the M3 screws is what I'm aiming for to have in the model. So click on that, and that's our first one. Now if we go, I'm just going to punch a hole in that straight away so you can see the whole process. Normally I'd add all the other shapes, but we're just going to do this one hole to start with. So I'm going to go back to the axiometric view, and we might as well go back to the solid as well. And then the next thing to do is to actually select that sketch, and we want to punch the hole in it. So if I close that, we go down to sketch here, and there's the punching of the holes. It says create a pocket with a selected sketch, so punch, and I'll just go to through all. And yeah, that's it. So now if I look at the top one, for instance, you can see that that's a hole in the corner of that one. So that's how easy it is to do it at that stage. Right, so this is my final design. I had to lengthen this a little bit to allow for the battery, which I'd forgotten in the original design. There's the 4 M3 screw holes on the outside. This one here is the panel which will end up putting the double 8x8 matrix in. There's the hole for the button which will set the time, and there's the hole for the button which will turn the clock on and off. So to export it now to STL, you just press on, well, this is what I did, there might be other ways of doing it. I just press on the top layer here, and I go to File and Export, and then you select STL, Mesh Formats, and there it is there, Clockbox STL. I'm just going to call this one Fred, because I've already done this, and I'm going to save that. And that's all there is to it. Let's go and have a look at how we slice it in preparation for 3D printing. Okay, here we are on Ultimaker Cura, so I'm just going to go and grab that STL file, Fred, and there it is down the bottom, and you can, I guess look at it various rotations and so forth to see if that's exactly what you're after. But yeah, I'm pretty happy with that, so that's fine. Then there's a couple of settings to make about how fine that you would want it. So you could say, okay, I want 0.2 with a 30% infill, I want support, I want adhesion, and you can also press custom here, and you can do things like something which I often do is change the temperatures, but I'm pretty happy with that at the moment. And then you just press slice, and also you can press preview, and it shows you what it's going to look like on the actual bed itself, and that's it. Last thing to do is to actually, what we're going to do is save that to file. So there's Fred G code, and we'll save that. And that file is now ready for the Octoprint in my case. Or if you don't have Octoprint, you can just put it on your SD card, take it down, plug it into your 3D printer. That's it. So this is Octoprint doing its thing. We're about 5% into the print. Did have an issue this morning with Octoprint trying to access 2 ports at once to the printer, so I did solve that by going into the preferences and saying please just use USB 0, so it seems to be working now. And yeah, it's not a very exciting interface really. I mostly look at this area here, but you can, I guess, do some other things if you know what's going on. So there's just a I guess a shot here of what's happening, which is fine. You can also, if you like to read G code or what's happening on the terminal, there it is. But basically, keep an eye on the temperature, and I keep an eye on the process. So we're at 6% at the moment as we go through, and I can monitor that from anywhere in the house, usually using an iPad. And then also we've got the ability to, let's say, turn on the flash. It's actually already on there, and take a still, so we can see what's going on at various points. I just keep pressing the button there and just keep getting stills. Or we can actually start the stream and have a look at it. I'm not very happy with those. That's a little bit better, I guess. That's interesting. Getting the different colors and so forth. So yeah, you can change the quality of that. Not seeing an awful lot. Of course, the problem is too that this is black filament that I'm using. But I might have to light that better actually to see what's going on. But anyway, that's pretty straightforward to get all that going. So we'll see what happens when it's finished. So now it's just a matter of putting the components together. So there's a bit of wiring to be done. So I've put it on its own little PCB there, just looking at the layout, and I've got all my components and so forth ready to go. So the next thing to do is to start wiring it up. And then we'll try and fit it into there's the plastic front, which is just checking the layout really of those switches, and starting to wire up the components. Here the wiring is almost complete, so all that's going to sit behind that plastic front, and there it is complete. One of the things which I did forget initially was space for the battery. So if you check back to my original design diagram, I've had to add an extra couple of centimeters at the bottom there to fit the battery, but yeah, it all fits pretty neatly together. And there it is on the fridge. So I've just put some M3 screws through there to some magnets so that it's fixed on the fridge, and we'll see it click over from 401. It goes into a sort of like a random dissolve pattern, and then comes back at 4:02. There it goes. You know, I'm not entirely happy with my hot glue skills. You can see the button to change the time is pretty naff. But for first up effort, yeah, that's not too bad, I suppose. It's working fine. And there it is again in all its glory. So, yep, that's the circuit working. See you next time.